Hello everyone. I am Dr. Rimpi Foujdar, currently working as an assistant professor in the Department of Food Technology. Today I am going to deliver one lecture on the introduction to nanotechnology and its application in food industry. In this lecture, I will cover basic definition of nanotechnology, what are their impact areas, examples, history, classification, synthesis approaches, and their application in food. So first, we should understand that what is nanotechnology? Nanotechnology basically deals with the nanoscale designing, characterizing, and producing structures, devices, and systems by controlling shape and size for their application in various fields. So this nanoscale is basically dimension is considered that is 100 nanometers or less. So 100 nanometers or less based nanoscales are considered as a comes under the nanotechnology. So nanoscience and nanotechnology, basically nanoscience is the study of the science at molecular or atomic level and of the nanoscale level. And this nano impact areas of nanoscience are chemistry, biology, physics, engineering, surface sciences, biotechnology, and molecular biology. And this application of nanoscience in the designing of any materials and its application in the field, the nanotechnology actually classified. And the impact area of nanotechnologies are energy, chemicals, sports, telecommunication, IT, construction, transportation, healthcare, aerospace, defense, and food and agriculture. So these are the impact areas of nanoscience and nanotechnology. Further, in the nanotechnology, we should know about some general terms. So these are the all general terms which are related to the nanotechnology. Nanoscales, which that means having one or more dimensions of the order of 100 nanometer or less. Nanoscience is the study of phenomena and manipulation of material at atomic, molecular, and macromolecular scales where properties differ significantly from those at a large scale. The design and nanotechnology basically deals with the design, characterization, production, and application of structures, devices, and systems by controlling shape and size at the nanoscale. Nanomaterials are materials with one or more external dimensions or an internal structure which could exhibit novel characteristics compared to the same materials without nanoscale features. Nanoparticles are those particles which have one or more dimension at the nanoscale. Nanocomposites, composites in which at least one of the phases has at least one dimension on the nanoscale. Nanostructures are the structure having nanoscale. So these are the general terms. Further, let's discuss about history. So the importance of nanotechnology, that is the manipulation of matter at very small scale, which is actually the terms was first defined by American physicist Richard Feynman. In his famous lecture, there is a plenty of room at the bottom. Although he did not coin this term, and that is nanotechnology, Norio Taniguchi, who was Japanese scientist, who mentioned the term nanotechnology for the first time in 1974 in his paper on synthesis technology to create objects and make features of nanometer dimension. So what are the examples of nanotechnology? Nanotechnologies already exist in natural world. So those examples of of nanotechnology that is exist in natural worlds are DNA, water, antibody, virus, fungi spores, red blood cells, bacterial cells. So these are the examples of natural world based nano scale dimension, nanometer dimensions. Further, the engineered nanomaterials or nanostructures, the examples of engineered nanostructures are liposome, micelle, gold nanoparticles, quantum dots, magnetic nanoparticles, dendrimers, and carbon nanotubes. Now, the big question is that why nanotechnology is a focused area for the researchers. So many of the application of nanotechnology involve new materials that have a very unique properties and new effects as compared to same materials which is made at a larger sizes. So basically why? Because this is due to the very high surface to volume ratio of nanoparticles as compared to larger particles. So what are those unique properties? Unique properties might be in the term of mechanical, thermal, melting, electrical, magnetic, catalytic, diffusivity, and optical properties. So here, uh, for better understanding, this figure actually illustrates the particle size. As the particle size is reduced, the surface area is increased. So as the surface area increase, the reactivity is also increased. So even a small quantity of molecules, the reactivity, we get a high reactivity at nanoscale level. In this figure, we can observe that the unique optical properties of silver nanoparticles. In first, you can see that the silver nitrate solution in initial conditions, they are in transparent color. But when they are converted into the silver nanoparticles, this transparent color is going to convert into dark brown color with the addition of plant extract or chemical compounds that act as a reducing agent. So it is a unique optical properties of silver nanoparticles. Similarly, the particles, further reduction of the particle size, the color is basically changed from the red to blue, and this uh, changes of colors basically defined as a quantum dots, and it's used as fascinates in labeling purposes. Now comes on the classification of nanoparticles. So nanoparticles are classified on the basis of different aspects, on the basis of dimension, origin, composition, phases, and dispersion. On the basis of dimensions, the nanoparticles are classified as 0 dimension, 1 dimension, 2 dimension, and 3 dimension. The examples of 0 dimensions are gold quantum dots, nanoclusters, nanoparticles. Then the examples of one dimensions are nanotubes, nanofibers, nanowires, nanorods. Then examples of two dimensions are graphene, styrene, phosphorine, etc. And three-dimension examples are nanocomposites, nanocrystalline materials, and nanostructures. On the basis of origin, the nanoparticles are further classified as engineered, incidental, and natural. Engineered are basically based on the synthesis approach of nanoparticles, that is top-down and bottom-up methods. And the incidental means accidentally they are produced due to the various environmental conditions. That might be storm, cosmic dust, volcanic activity. And the natural nanoparticles examples are micro and higher organisms at nanoscale level. On the basis of the composition, the nanoparticles are divided into carbonaceous, organic, inorganic, composites. And on the basis of phases, they are divided into single phase and multiple phase. And on the basis of dispersion, they are divided into dispersed phase and aggregated phase. So these are the basic classification of nanoparticles on the on a different aspects. Now let's understand what are the synthesis approaches that exist for the development of nanoparticles. So we can develop the nanoparticles through using top-down approaches and bottom-up approaches. So what is top-down approach? The top-down approach is basically involved breaking down larger materials into smaller nanoscale structures. The examples of top-down approach methods are mechanical milling. In mechanical milling, that is mechanical milling, then is sputtering techniques, nanospraying, ultrasonication. And in the bottom of synthesis, the methods are Sol-Gel methods, self-assembly methods, then co-precipitation methods, and chemical vapor depositions methods. So these are the basic example of methods of different approaches. Now comes on the application of nanotechnology in food industry. So application of nanotechnology in food industry is divided into two areas. One is the food processing and preservations, and one is the food packaging. So in the food processing and preservations, the nanotechnology is applied to modify the structure of foods. One of the example is the low-fat product design of low-fat uh, ice cream, low-fat based ice cream by the application of nano emulsion. So we know that the fat is basically contributes as a mouthfeel texture in ice cream. And so there is the reduction of the fat is very challenging, but the use of nano emulsion help to enhance the texture mouthfulness. So without hampering the texture of mouthfulness, the fat can be reduced by the application of nano emulsion. Another application of in the food processing and preservations are nano-encapsulated food additives. So some food additives are very unstable or easily degraded in various environmental stresses. So encapsulation within nanoparticles will improve the stability, and the nanostructure function compounds are another application in the food processing. So functional compounds, we know that functional compounds are considered as a bioactive compounds that have a health beneficial properties beyond its nutritional properties. And one of the major problem of this functional foods one of the major problems of the for the application of these functional foods in food processing is their instability, or they are easily degraded in various environmental conditions, including gastrointestinal tract. And their low bioavailability is another major challenge. So to improve those bioavailability and stability, the nanostructure is very helpful. So further, the other application is nanopreservatives. The nanopreservatives are very preservatives in the size of nanoparticles are very effective as compared to larger preservatives. Then toxin detection and antimicrobial nanoparticles. Other application, other areas is of the nano technology applications is covered in food packaging, is as nano coatings, nano sensors, nano composites, active packaging solutions, and edible coating nanomaterials. So these are all applications of nanotechnology in food industry. Now let's discuss about what are the existing problems and solutions of nanoparticles in food is available. So the problems basically is associated with the toxicity. So if we consider the nano food is basically divided into as a nano additives of food packaging, nano carriers or others. So they might be cause oxidative stress, DNA damage or protein denaturations in our body system. And to protect those, we can produce unified regulations and also use of low toxic materials. So here the low toxic materials can be considered as a the solution of the use of low toxic materials is the altering the use of chemicals to the biopolymer. So that is one of the major solution of using producing the low toxic or non-toxic nanoparticles. So for today, that's all for today. Thank you.